All right, Ex3I. Let's have a look at some notes here. Last session, I kind of alluded the idea that the reason why exponential and logs is hard for students to understand, or what I think is because it doesn't have an operator. Okay, so having an operator helps you to visualize what's happening. So last session, I showed you that when you add, that symbol there is an operation. And that operator helps you to visualize, well, what's the opposite of adding? You would then say, well, to solve this equation, I don't want x plus 3, but I just want x. So then you say, well, the opposite of that is minus. Same thing with times. You would say, well, the opposite of times, I don't want x times 3. I just want x. I don't want to triple it. So then you say, well, opposite of times is divide. Each and every one of them has an opposite operator. The problem when you come to indices is that when I ask 3 to the power of x is equal to 9, you know what this means. But if I asked you, what is the operator? It's not so visual. But the reality is that it's the positioning. The fact that you put the x in that little top corner, that is the operator. And that's what makes it confusing, unlike the first two. Yeah, so the first two you'd say, well, minus is the operator, and then how much am I minusing? It's minus 3. Here, division's the operator. Well, how much am I dividing? The dividing is 3. Well, similarly here now, you have to realize this exponent, that's why we call it exponentials. The exponent is the power. Okay, so this is called the exponent. When you have the exponent, that is the operation. That is your operator. And the opposite of an exponent is, and write this down, it is the log. Okay, so log is the operator. So write that in just like what you've done over here. Minus was the inverse operator on this side. So whatever you do to one side, you do to the other. Here, you would have said divide is the operator. So here, when you say log on the left, you have to also write in log of the right. So what I'm saying is you're actually typing log of, in brackets, 3 to the x. So that's what you're doing on the left side. That's equal to, and you're doing whatever you're doing on the left, you do to the right, so it's log of 9. This is the operator that's the inverse of an exponent. Okay? What I haven't done is the number. See, the operator was divide. Here we said, well, the opposite of divide or times is divide, but how much am I dividing? You said 3. So then I had to divide both sides by 3, right? So this is minus 3. Well, same with exponent. When you do log, there needs to be a number. The number is that base. So the base is currently 3. So I do log base 3 on the left. That means I do log base 3 on the right as well. So this is what you're actually doing. There's no different in all 3 columns at the moment. We're doing the same thing. So one has an operation, the other one's the inverse. One has a number, a quantity, and the inverse has the quantity in it too. I'm doing the same. But why is the third one so hard for students to get? It's because you're not used to seeing this as the symbol. That is the symbol. That's the operator. That's the number. This positioning is the symbol, and that's the number. Does that make a bit more sense? Yeah? Okay. Now, when you do the inverses, just like all of these, positive 3 take away 3 is 0. They inverse one another, so they undo. Just same thing, times 3 divide 3 cancels out. And then, well, when I do this, it's the same thing. Log 3 of 3 should also cancel out. All of them follow the same thing, that on the left side I end up with x, and that 8 minus 3 is 5. On the left side here is still x, and that's 12 divided 3, which gives me 4. Then the same thing over here, this is x is equal to, and we know that log 3 of 9, well, but I know that has to be 2 because 3 squared is 9. Okay, so log 3 of 9 equals 2. So all of them are doing exactly the same. Just visually, this one at the moment looks different. Okay? This is what I'm going to try to train you to do. So today's purpose or goal is to interpret that movement. Because what most students do is they don't actually learn it through this way. That's why when you get to year 11 and 12, and I'm still reteaching this so that they understand what the purpose is that they memorize this one. I don't want you to memorize that. Okay? Because what we're actually doing here, if you're wondering how this proof comes about, most students at year 11 and 12 are memorizing this conversion. They're just saying a to the power of something, if it equals y, then it'll be log of that base of y equals x. And they'll just memorize that. So if I gave them something like this, if I said 10 to the power of something equals to 1.5, they'll memorize this as, that's a base, so that's a, so they'll memorize it as log of 10, 1.5 is equal to x. That's what they memorize. Okay, but what they're not seeing is, how did I go from here to here? Okay, and if you follow what I just taught you, you can see how I moved from here to here. If you ever think, how did I go from here to here? Let's do it again. That's an exponential, right? That's my operation. The position's the operation. The number's 10. What's the inverse of an exponent again? Log. So I should do log on the left, log on the right. The number is 10. So I should be doing log base 10 on the left, log base 10 on the right. These two are inverses. They cancel out and you get x is equal to log base 10 of 1.5. That's where the conversion's coming from. Okay, so if you understand it from balancing the equation, then you can start doing things like rearranging, and then you can start doing the change of base formula and all that. Then the proofs that I talk about will make more sense. But if you try to memorize it this way, which is efficient, but at some point you're going to be stumped when you're trying to do applications and you're trying to solve problems, you're missing a skill. And the skill is very basic, exactly what you've been doing this whole time since year 7. You've been doing inverse operations, right? Whatever you do to the left, you do to the right. We're not changing that. It just looks different. Cool? So today's lesson is you're trying to get from that to that. That's what you're trying to do. Yep. Which part? This one. All right, let's do another one. I'll just do it on the side. Let's do another example. Let's do one that we don't know. Let's try, what's the one I recently did? I did 2 to the power of x is equal to 15. Okay, so I'm choosing a number that you guys can't figure out, right? On your calculators, because I think you guys have the senior calculator, is that right? You guys got the CAS calc, not the scientific? Good. So you should be able to do this on your CAS. So, your goal is to find x. Now to find x, the problem is, I need to get rid of that 2. Just like all the other problems before, you need to get rid of something, right? I don't want that 2. I just want x. But this is an exponent. So then you ask yourself, what is the opposite of exponents? What is that? Log. So the operation, you write down log. So you do log of the left, log of the right. So here we go. I do log of the right and left, right? So here's the equal sign is still there. On the left side, I've got 2 to the x. So log of 2 to the x. Here, I've got 15. So it should be log of 15. Just like that. Yeah.
I can't get the base of the calculator.
And that's why I'm gonna give you the formula for that. Yeah. I'm gonna show you. Let me go through this and I'll explain what Raf is finding a problem with there. Here we go. Shh. Eyes and ears towards the board. So we know that log is the inverse of exponential. But just like all the other ones, they all have to have a quantity, right? So divide 3, plus 3, times 3. This is log 2 because that is a base 2. That's an exponent base 2. So when you do the inverse, well, you need to do inverse log 2. That's the operator. That's the number. Just like all these examples here, that's the operator. That's the number. That's the operator. That's the number. Well, then same thing with log. That's the operator. That's the number. These two should cancel out. And I'm going to show on the cows so you can see, yeah? Log 2 of 2 will cancel out because they're opposites. And you end up with x is equal to, and remember, whatever you do to one side, you have to do to the other. So this should be log 2 of 15. Now, if you don't have the senior calculator, which I'll show you what it looks like. It's just there.
Yeah. It has been for a while and it charges really, really slow.
No, that's okay. I can show you how you can do it without a senior calculator because back then we don't have these calculators. So how do we do it? So on your CAS calculator, you'll find on the side it should say ln, okay, or log, log. Now when you do log, I'm just going to move it aside so you can see on the screen. See that? X squared, and then underneath there's the log, there's exponential, there's an ln there. Log, if I do control 10 to the power of x, it gives me a template. The nice thing is that your calculator is now actually, you can do any base. In the past, my time, I didn't have a calculator that could do the base 2. We didn't have base 2. We only had base 10 and we had base E. That's it. There's no more base 2s. So with the problem that you have now, you're typing base 2 of 15. That's 3.90608. Yeah? If what that's saying is 2 to the power of this will give you 15. That was my first question. My question was 2 to the power of what will give you 15? So if you type it in, 2 to the power of that decimal, whoops, it's 15. See that? So it's that logarithm that you're using. What's the problem? So how do you do it on a scientific calculator? I'm not going to teach you how to do this formula yet, but I'll teach you the rule. Okay, so here's the rule. It's called a change of base rule. Copy it down. I don't know if I wrote it in your notes yet. Let me just check. Did I have it in your notes? No, I didn't. All right, find some space. Write this rule down because it'll be useful if you don't have a senior calculator. The rule is, if you've got a log A of M, so something that you can't work out with because of the base, right? This is called a change of base formula. You can then do the log B, which is base, whatever base you want, of M divided by log B of A. Later on, once you guys get really good at logs, I'll prove this for you. I'll show you where the proof comes from. Okay? But at the moment, write this one down.
Where do you write it?
Write it somewhere on your sheet, just a little corner somewhere. So here's the example. Ralph wasn't able to do log 2 of 15 because he doesn't have the senior calculator with him now. But you can do it on a scientific. This is how you do it. I don't have a base 2. So back then we didn't have a base 2. So how do we do it? We only had base 10 and base E. And I'll tell you much later in the history why that's the case. But in that case then, well, I can change the base to whatever I want. So the answer would be log base 10, because I've got that on my calculator. So if Raf types in the log, if he presses log, it's a natural base 10. Okay, it's automatically assumed it's base 10. So if you type log, it's base 10. If you type ln, that's log base E. Okay, so right now I want a base 10. So then m is currently 15. So I do log 10 of 15 divided by log 10 of A, which is the base that I didn't have, log base 10 of 2. This I can type on my scientific calculator. So if you watch, if I do it on my senior calculator for you to see right now, let's do it on the side. Watch what happens. So we know that the answer is meant to be 3.906, right? So log, do control, log base 10 of 15 divided by log base 10 of 2. So I'm just going to fix the bracket here. I should get the same answer. So that's how we used to do it with our scientific calculators, and we didn't have a graphics calculator the way you guys have now. Then that's how we had to do it. And we had to learn this rule. But to learn this rule, you had to learn logarithms the way I was just showing you. You have to learn how to balance the equation. Okay, don't memorize it. Learn how to balance the equation. Then you can work out this rule. Okay? So, if you don't have the senior calculator, that's the rule that can get there. Okay, but today's lesson, I'm just trying to teach you how to interpret logs. Okay, so let's go. Let's go down. Let's fill in some notes here. So that means there must be an operation to undo, and that is called logarithms. Okay, so opposite of multiplication is division. Then the opposite of exponents is logarithms. Okay. Summary. 3 to the x is equal to 9. We know the answer was 2, but what I showed you just now is that was log base 2 of 9.
Wasn't it log base 3?
Was it base 3?
Yeah.
Oh, sorry, I couldn't read my own handwriting. Yes, you're right. Log base 3 of 9. So again, Back then we couldn't do that, so we'd have to use the change of base formula, and that would have done log base 10 of 9 divided by log base 10 of 3. You would get the same answer. Okay? Now, let's practice. So, in the worst case scenario, if you didn't understand my inverse operations, both left and right, then you can memorize this formula. I don't recommend it, but you will get through up until year 11 and you get stuck. Okay? But that will get you through. Yeah? So to do today's exercise, let's do a couple examples to get you feeling it, okay? Here we go. They want you to write an equivalent exponent statement for the following logarithms. Let's do the first one. See that? A lot of the times, this doesn't mean anything to most students. I'm going to teach you to interpret what this is, okay? You didn't realize logarithms allows you to find the power. Okay, so it was 2 to the power of what gives you 15? You're always looking for the power. So what this is asking, when I look at this, I see it as 2 to the power of 4 equals 16. That's how I see it. But for you guys, I'm going to train you guys to get to that point. So how did I do that? Here we go. What's the opposite of log?
Exponent.
Exponent, that's right. So the exponent, which unfortunately doesn't have an operator. We don't have it like a symbol. So that's why it makes it a bit tricky here. But we know it's exponent, and number 2 is, the number is 2, right? So I've got exponent, and I need a 2. So how do I do an exponent? It's 2 to the power of whatever's on the left. Yeah, so I do 2 to the power of log 2 of 16. But what if I do to one side? I have to do to the right side. So here I do 2. You told me it was exponential, so 2 to the power of 4. Can you see that? So unlike before, we're now doing the opposite of log. You told me it's exponential, but exponential doesn't have a symbol. It's the positioning. That's my positioning. It's 2 to the power of whatever this is, and then 2 to the power of whatever this is. Where did I get the 2 from? Because it's log base 2. So then I did exponent base 2. Does that make sense? So exponent base 2 on the left, exponent base 2 on the right. Now you can see exponent base 2 to the power of log base 2, these are inverses. So they're going to cancel out. They're going to cancel out and give you 16 is equal to 2 to the 4. And this is one of the trainings that you're going to try to do in the first exercise here, is that you're trying to read. When you read that, this is what you should be seeing in your head. When you look at that, this is what it means. You're saying 2 to the power of 4 equals 16. Okay, so 2 to the power of 4 gives you 16. That's the result. This is the power. Okay, that's what we're trying to do. So we're converting. I just balance the equation. Now I can show you on the CAS how exponents and logs cancel out. Okay, I'll show you on the CAS. Here we go. Let's do an example. So if I did x plus 3, opposite of plus 3 is take away 3. Answer still x, because they're opposites. They cancel out. If I did x times 3, then the opposite of times 3 is divide 3. You still get x. So same thing with logarithms and exponentials. If I did 3 to the power of x, right? Then the opposite of base 3 exponential, or exponent base 3, is that it's log. So if I do log base 3 of, whoops, let me just retype that again. 3 to the x. Can you see how they're opposites of one another? The answer should still be x, because they cancel out. If I do the other way, if I said 3 to the power of, and I wrote log base 3 of x, you see these are inverses of one another. This is an exponent base 3, that's a log base 3, they're inverses just like all the other ones. The answer is still x. And that's what you're learning at the moment. You're just learning to balance the equation, that there is another operation, it just doesn't have a symbol. It's the log. And exponents is the positioning. Okay? All right, let's practice. Let's read this one. See again. Let's balance it. What's the inverse of log again? Exponent. What's the base this time? A. So what I need to do is I need to do exponent base A on the left, exponent base A on the right. So here we go. A to the power of log A of A. And then on the right, A to the power of 1. See, that's my right side, that's my left side. I did the inverse of log, which is exponent, and it's base a. So it's a to the power of that, and then a to the power of that. These two are inverses, so they're going to cancel out. And then you're left with a is equal to a to the power of 1. But it's about reading it. So when you see something like this, what it's saying is a to the power of 1 equals a. Okay, so that means if I gave you something like this, let's test your understanding now. What if I gave you something like this? What if I said log base 7 of 41? Very good. That's what you're reading. That's what I want you to get to. Okay, so when you look at this, you should be thinking, this means 7 to the power of what? Will give you 41. That's what this is. Okay, that will tell you what the power is. So if you type that in your calculator, that will tell me what x should be. That's the power. That's what logarithms does. How's that feel? So far, so good? Let's do a couple more examples. There we go. Wait, oh, was that it? I thought I had a few more. Yeah, here we go. All right, let's go down this one. Turn over. Flip over. All right, let's try to write this one. Same idea. So you can do the conversion, or you can do what I just taught you. We know that 3 to the power 4 equals 81. So if you want to change it to log, get rid of that base 3. That's an exponent base 3. So what you need to do is you got to do log base 3 on the left, log base 3 on the right. On the left, I got 3 to the power 4. On the right, I've got 81. See how I'm balancing the equation? Opposite of exponents, log. That's base 3, that's base 3. These two are inverses. They're going to cancel out. This one, that's what I'm trying to figure out. So this cancels out. 4 equals to log base 3 of 81. So if you did log base 3 of 81 on your calculator, it should equal to 4. Now you can continue doing the algebra, but hopefully at this point you can start to convert it in your head now. What's b to the power of 0 equal to 1? If I want to write it as a logarithmic statement, what would it be? Log base b of... I want a statement here. So what should it be? Change that to that statement. What would it equal to? Like that? We're happy with that? Very good. So that, if you couldn't do that conversion, that's okay. Take your time to do the algebra component. Okay, so if you weren't sure, you could have done log base b on the left, log base b on the right. These will cancel out, and 0 equals to log base b of 1. And you would have got there too. Okay? All right, team. So when they ask you to evaluate this now, so you learnt the basics. Let's try to evaluate this now in your head. What's log 7 of 49? 2. Very good, because this is saying 7 to the power of what? Gives you 49. You're looking for the power. Right? So if you interpret it, this actually just means 7 to the power of what? Equals 49, and we know the answer is 2. Okay, if you didn't know that, you can make it up. You can make an equation for yourself. You could have done log 7 of 49 equals something, and then do what I just taught you just now, and you would be able to get to this step. Okay? So it's about interpreting. That's today's goal, interpreting the log. Let's do this one. What about log 3 of 1/9? -2. Oh, yes, -2 is correct. And again, same thing. If you read what this is saying 3 to the power of what equals 1/9? That's the same thing as writing 3 to the power of -2. Because that's 1/3 squared. Using index law number 7, you can flip it. I skipped a step. I'll just write it again. 1/3 squared. Therefore, x is equal to -2. All right, team. I'm going to pause the video, and I want you to try to answer the next 2 questions. Have a go with these ones. I'm going to pause the video. All right, let's continue. So, hopefully you're able to balance the equation Opposite of log is exponent. So it should have been 5 to the power of log base 5 of x. So 5 to the power of whatever's on the left. 5 to the power of whatever's on the right. Base 5 and log 5 cancels out. So you should have x is equal to 5 to the power of 3. And that essentially means x is equal to, very good, 125. Okay, it's all about doing the balance in the equation. Same thing with the next one. I've got a log. The opposite of log is exponent. So it means it has to have a power. So I need exponent base x. So x to the power of log x of 10,000 is equal to x to the power of 4. This gives me 10,000 is equal to x to the power of 4. Now you can do a bit of guessing here. You could probably at this point, something times itself 4 times to get you 10,000 and you would have figured it out. But if you learned from what we did so far in chapter 3, you can break this one down. 10,000 is the same thing as saying 100 times 100. But then 100 times 100 is the same thing as saying 10 times 10. So you can see 10,000 is equivalent to you writing 10 to the power of 4 is equal to x to the power of 4. By comparison, x must be 10. By comparison. Okay, so if you then change that to an exponent, break it down just like what you've done in so far, that's how you do that question. All right, or you could have trial and error. All right, team, first, that's the exercise logarithm. That's an intro. Next lesson, I will then teach you some logarithmic rules, but you first have to be able to interpret logs. Okay, you have to be able to read what a log is. All right, I'm going to stop the video.